Hey guys, this is the full review for exam one, so I'm going to go over all of the questions from that assignment. Now, when your full review for exam one generates, might generate different numbers here, like different expressions, but it should be the same sort of assignment. Also, if you want to just follow along with me because you are not doing this as the full review exam one assignment, you're just reviewing for the exam. Please print off the notes that I have so that you can work along with me and you will get the same notes. Because if you just go to my math lab, those numbers will not be the same for each question. Okay, so this review will include every problem type that will show up on the exam. So if you understand this, you know that you are ready for the exam because the exam is just going to be much shorter than this, but it will be these same type of questions. All right? Okay, so number one is complete the sentence below. The polynomial 2x to the fifth minus 3x to the fourth plus 12x cubed minus 2 is of degree what? And the leading coefficient is what? Now, remember in that first lesson of our course that coefficient does not include the variable, okay? The coefficient is the number in front of the variable. So they're asking for the leading coefficient and the degree. What you want to do when you have a polynomial is you first need to make sure that it's in descending order, not of the coefficient, not of the number in front of the x, but of the power of the x, the exponent. So we have a 5, a 4, a 3, and then a 0, right? 2x to the power of 0. You could think of that too as. So it's already in descending order. If not, you would want to change them around. So the question might trick you and might put 2 negative 3x to the fourth plus 2x to the fifth. You'll want to switch those around to make sure that your leading coefficient is actually also the term with the highest exponent. Okay, so that's already in descending order. So it's of degree. You just take the biggest degree of the entire polynomial. So that's a 5. And the leading coefficient is 2. Leading just means first, right? So once you have it in order, what's the first coefficient of that entire expression? It's the number 2 because it's 2x to the fifth. Good. And this is just your drop down box. So you would pick a number here and you would pick a number here. Number 2, state whether the following expression is a polynomial. If it is, give its degrees. If it is not, state why not. All right, what is the definition of a polynomial? Poly means it's multiple terms and it has a variable, right? It is a polynomial and the degree is 5. Ways it might not be a polynomial is if the exponent of the variable term is not a non-negative number. So many double negatives, not a non-negative number. So you can take away both of those nots and say if that number right there, if it's a really long one, any of these numbers, if any of these numbers is a negative, that's not a polynomial. Or it's not a polynomial because it has the difference of two monomials, or it has division, okay? So if there's division involved, or if the exponent is a negative number, it would not be a polynomial. Number 3 says multiply the given polynomials and express your answer as a single polynomial in standard form. Standard form means it's not in factored form, okay? That is, all right, sorry about that. Somebody rang the doorbell. Um, so it's asking for standard form. Standard form, it looks like this, where you don't have any parentheses. It's all been multiplied out. This would be factored form. The first step that we're going to do when we have parentheses and then a power is you don't distribute that to the 2x and then to the negative 7. What you do is you turn it into, I'm going to give myself a little bit more space, so maybe right up here. You turn it into 2x minus 7 times itself. Good. And that would still be considered factored form. It's just a different factored form than that one. So we need to turn it into standard form. Standard form just means now you're going to FOIL it, right? First, outside, inside, last. So first, we have 2x times 2x. Outside, 2x times the negative 7. Inside would be the negative 7 times 2x. And then last is negative 7 times negative 7. Then we're just going to go through and solve them. So 2 times 2 is 4. X times x is x squared. So we have 4x squared. It's a positive, right? Then we've got a 2x times negative 7. So that's negative 14x. And then you've got the same one there. Negative 7 times 2x is also going to be negative 14x. And then negative 7 times negative 7 is a positive. Negative times negative is always positive, 49. So then we change that. We write that all down here. So we take that 4x squared minus 14x minus another 14x plus 49 because that was a positive. Good. That negative just becomes a minus sign. Now we can combine the like terms. The like terms are negative 14x and negative 14x. So that becomes 4x squared minus 28x plus 49. And that would be your simplified answer in standard form. 4x squared minus 28x plus 49. Good. All right, now we're going to do the opposite. We're going to factor the polynomial. First of all, make sure that it is in descending order. So we have an x squared here, and then an x, and then an x, or an x to the first, x to the first. We have a y squared, and a y. Now, when you're taking the degree of this one would actually be 3 because you have an x squared here and you have a y. You can think of that as a y to the power of 1, right? And that x is an x to the power of 1, so that's a whole degree of 3, and that's also a degree of 3. So it doesn't matter which order you put them in. It's also nice to have a positive as your leading coefficient. If you did not have a positive as your leading coefficient, you would factor out a negative 1, right? So let's just pretend that it was negative 8 xy plus, xy squared plus 2x squared y plus 4xy. If that was your case, your leading term is a negative. And so if the leading coefficient is negative, you factor out a negative 1. What you do here is you just take negative 1. Negative 8xy squared divided by negative 1 is just 8xy squared. A positive 2x squared y divided by negative 1 becomes a negative 2x squared y, and then a positive 4xy divided by negative 1 becomes a negative 4xy. So now you've basically just changed all your signs by dividing out a negative 1, but your leading term is positive. You need your leading coefficient to be positive. In this case, it already is, so we're just going to factor the polynomial. We have 2x squared y minus 8xy squared plus 4xy. What is common to all of those? Well, there's an x in all of them, right? What's the biggest x that we have? Just x, right? So we can factor out an x. How should we do that? Should we do it like that or should I do it like this? I should do it like this. Ignore him. We're going to factor out an x because it's common to all three terms. We can also factor out a y because it's common to all three terms. There's a y here, a y squared here, and a y here. The smallest one is just y to the power of 1, so we can only factor out one y. And then the numbers 2, negative 8, and 4 all have a common factor of 2. So we're going to divide all of these terms by the exact same term we are factoring out, which is 2xy. So 2xy. When we take 2x squared y and divide it by 2xy, 2 divided by 2 is just 1. So you can either put 1 or you can put nothing here, okay? X squared divided by x is x, and then y divided by y is also 1. So it's just x. All that's left there is x. Negative 8 divided by 2 is a negative 4. The x's cancel, and you have one y remaining because one of the y's cancels. Plus 4 divided by 2 is 2. The x's cancel and the y's cancel. So the factored form is 2xy times x minus 4y plus 2. You don't need to worry about factoring it any further because there is no term that, there are no two binomials that if you combine them together, you would get x here and a y here. All right, so that's the factored form. Next question is factoring by grouping. We have 9x squared plus 12x plus 6x plus 8. You can just look at those terms and make sure there isn't anything you can factor out even before you do factoring by grouping. So if these were all divisible by 3, if they were all divisible by 2, if you could take an x out of all of them, you would do that first, but that is not possible. And so when that's not possible and you have 4 terms, they often ask you to factor by grouping. You can group them however you want. I just go right down the middle, okay? So that becomes 9x squared plus 12x, and then 6x plus 8. Good? I'm going to do it over here. So we've got 9x squared plus 12x as the first term, and we're going to find a common factor between those two. I think they can both be divided by 3, right? And they have a common x, so we can even do 3x. Good? So that becomes 3x. 9 divided by 3 is 3. X squared divided by x is x. 12 divided by 3, keep that positive sign. 12 divided by 3 is 4. And then the x and the x cancel. So that becomes 9x squared plus 12x becomes 3x times the quantity 3x plus 4. You didn't really need these. Sorry, I thought I was going to write them both at the same time, but I didn't. Good? So the first two terms become that term. We're going to take the other two. The other two are positive 6x and the number 8, okay? And we need to think about what we can divide out of 6 and 8. There's no x that's common to both of them, so it's just going to be the one number, right? 6, you can divide it by 3, and you can divide it by 2. Or you could divide it by 1, right? 8, you can divide by 4, and by 2, and by 1. So the greatest common factor is 2. So that will become 2. 6x divided by 2 is 3x. And 8 divided by 2 is 4. Good? All right. So these are our two terms. Instead of all of that, you have this, right? And we're going to add them because there was a positive sign. Oops, sorry, you couldn't see that. We're going to add them because there's a positive sign between them. And now what you want to do is you want to continue factoring. What does that mean? That means that there's a term that is common to both of these terms that you can factor out, and it is the binomial 3x plus 4. Here, 3x is being multiplied by 3x plus 4, and here 2 is being multiplied by 3x plus 4, so we're going to factor that out. I know it sounds odd. 3x plus 4 is one of the factors, and then we are left with 3x and 2. Good. So that is the factored form of 9x squared plus 12x plus 6x plus 8. I'm not even going to try to fit it in that. 3x plus 4, which is the term that we factored out. And then the leftovers were a 3x and a 2. So that becomes our other binomial. Good. All right, we're going to do it again. X squared plus 2x minus 6x minus 12. First thing you should do is look for any common factors between them. Do they all have a variable, or are they all divisible by 2? They are not. So we have to do the same thing again. All right, so we're going to factor the following expression. We have x squared and 2x are going to be my first two terms. What can I divide both x squared and 2x by? So those are those two. I can divide them both by x. and that gives me x. X squared divided by x is just x, and then a positive 2x divided by x is a positive 2. The other half is a negative 6x minus 12. When you have a minus sign, that means that what you're factoring out needs to be a negative, okay? So factor out the negative or else you won't get that x plus 2 as a common factor. Good? What can you divide out of negative 6x and negative 12? You can divide a negative 6. Remember, it has to be negative. So now we have a minus 6 times negative 6x divided by negative 6 is x, and negative 12 divided by negative 6 is actually a positive 2. So what we have here is this term and this term. What is common to both of them? The x plus 2. And what is left over when we take out the x plus 2? We have an x and a minus 6, or a negative 6. We have x minus 6. So the factored form of x squared plus 2x minus 6x minus 12 is x plus 2 times x minus 6. Good? Okay. Now we have x squared minus 15x plus 56. Sorry, I have to keep pausing this. All right, so for this last one, number 7. So for number 7, we want to factor this polynomial. We cannot factor anything out of it because it does not have an x in each one, and there are no common numerical factors. So for these, remember, this is in form ABC, where you want to find, in order to factor it, you want to find two numbers that are able to add up to b, which is negative 15. So you want them to add to negative 15 and multiply to equal a positive 56, right? What are some numbers that multiply to equal 56? Well, you have the numbers. And notice that this is a negative that has to add to, but it needs to multiply to a positive. So we're going to go all negatives, right? So negative 1, negative 56. And what you can do with your calculator is just take 56, divide it by 2. We get 28. So negative 2 and negative 28. If I add them, are they going to be equal negative 15? They are not. So 56, I don't think it divides by 3. 4 is negative 4 and negative 14. Would those add up to negative 15? No, but we're getting closer, right? 56 divided by, it's not going to be divisible by 5. Is it going to be divisible by 6? Probably not, because it ends in 6, and so it would have to be divisible. Can you divide, because does 60, or sorry, is 50 a factor of 6? It is not. So I'm going to skip 6, and I'm going to divide by 7, and I get 8. So negative 8 and negative 7. If I add those together, do I get negative 15? I do. And so those are the two we're looking for, because a is just 1. So we say x minus 8, because it's a negative, times x plus 7. Sorry, that goes down here. And that's our answer, because we found two numbers that multiply to equal the c, the 56, and that add to equal b, the negative 15. Good? So it would be negative, or sorry, x minus 8 times x minus 7, the quantity. The quantity x minus 8 times the quantity x minus 7. On to the next page. So this is just another way we're going to practice that, what we just did with number 7. And it is that we need, I just like to make a table. We need it to add to negative 2, and we need it to multiply to equal negative 48. So those are both negatives, so we're going to have one negative term and one positive term. So we need to find two numbers with only two integers difference, right? So it's not going to be, and the bigger number needs to be the negative 1. So I'm going to make it a positive 1, negative 48, for example. But that has a huge gap between them, so they're not going to add up to negative 2. We've got 2 and 24, right? When you divide it by 3, you get 16. So you got a positive 3 and negative 16, but that's not going to do 2. 48 divided by 4 is 12. So negative 48 divided by 4 is negative 12. It's not going to be divisible by 5. 48 divided by 6 is 8. So we're going to do a positive 6 because that's a negative. So the bigger number has to be negative, and a negative 8. See how when you add those together, you get negative 2, and when you multiply them, you get negative 48. So this one is going to be x plus 6, x minus 8. Make sure you get the signs correct because the whole answer will be wrong just because of your sign being off. Good? All right, we'll do it again here. Here we have x squared plus x minus 30. Do it up here just because I don't have a ton of room on this page. So that plus x is just a positive 1. So it needs to add up to 1 and it needs to multiply to negative 30. Now remember, it is possible to just not have an answer to this, right? Maybe you get through every factor pair and there's none of them, and that's okay. You just say polynomial is prime. Good? All right, negative 30. It's going to multiply to a negative and add to a positive. So that'll be kind of the opposite of this one, where you'll take make the higher number positive because you need it to add to a positive number. So we've got negative 1 and positive 30, negative 2, positive 15, negative 3, positive 10, but none of these are going to combine to equal positive 1, right? I don't think 30 is divided by 4, but negative 5 and positive 6, right? So that'll work. So our answer will be x minus 5, quantity x minus 5 multiplied by quantity x plus 6. Good. All right. These are a little different now because now when we're doing the A, B, C, A is not 1. A has a 6. So what you need to do for these is you need to find a number that multiplies to the quantity A times C. So 6 times 1. So it needs to multiply to equal 6 and add to 5, both positives. Multiply to A times C, which is what we were doing up here too, right? But here, A times C is just 1 times negative 48. A times C is just 1 times negative 30, right? And then, so we want it to multiply to equal A times C and add to equal B. A times C is going to be the number 6. Put it down here because I'm out of room already. And then it needs to add to 5. Good. So they're both positive, so we're going to keep everything positive. We've got 6 times 1. We've got 3 times 2, right? Anything else? Do 6 and 1 add to 5? No. Do 3 and 2? All right, so 3 and 2 add to 5, and they multiply to 6. You're not just going to say x plus 3 x plus 2 because a was not 1. We can only do that when the a is a 1. When it's not a 1, what you have to do, because watch this, if you multiply it out, x times x only becomes x squared, and we need it to equal 6x squared. Ignore that. Good? Um, so instead of that, what you're going to do is you're going to do something similar to what we do when we factor by grouping. And that is, you're going to take A, keep it the same, take C, keep it the same. So we still have 6x, and then we have plus 1. And instead of B, we're going to put in the two factors of B. So instead of saying 5x, we're going to call it 3x and 2x because those still add to 5x, but now we can factor it by grouping. Also, it completely does not matter which order you put it in. You could put plus 2x plus 3x, it will still work, okay? If you want to think about it and think, okay, 6, it's easier to divide by 3, or 2. if there's an easier way, you can put them in that order, but it doesn't, the order does not matter. Now that we've got that, we're going to factor them by grouping. I'm just going to take 6x plus 3x. Think, what can I factor out of 6x and 3x? What is common to both of them? I'm going to say it's a 3x. And so what I get is 3x. 6x divided by 3x is just the number 2. Positive 3x divided by positive 3x is just a plus 1, right? They cancel, but you don't put a 0, you put a 1 because it's 1. Good. Any fraction that is the same on the top and the bottom is just equal to 1. All right, and then we take those other two. We have 2x. It's a positive, so that's good. So we've got a 2x. It makes it a little easier. You don't have to make the divisible term a negative number. Whereas if that was a minus sign, the divisible term would have to be negative. All right, 2x and 1. Is there anything common to 2x and 1? Well, 1 is just 1, right? So the greatest common factor is just going to be 1, and that is completely fine. So we're just factoring out a 1. Put a plus there. 2x divided by 1 is just 2x, and then 1 divided by 1 is just 1. So now I have 3x times the quantity 2. Sorry, I forgot that squared. So that would actually be a 2x. Whew, luckily, right? You don't notice until you have to compare them. So that would be 2x plus 1 times the quantity 2x plus 1. So you can factor out the 2x plus 1. And you get 2x plus 1 times the quantity 3x plus 1. Good? Okay. It's not prime. Number 11, factor the given polynomial completely, or it is prime. Again, we want it to multiply to equal a times c, and a times c is a negative 8 times 3, which is a negative 24. Good. And then it has to add to a positive 23. What a puzzle. Negative. Okay, so it needs to multiply to a negative, but add to a positive. So that means you need a big gap between the two terms, right? The two numbers, and you need the bigger number to be positive. So we'll start with negative 1, positive 24, right? And when you combine negative 1 and positive 24, you get positive 23. Remember, we keep a the same, so it's 3x squared. Instead of negative 23x, instead of the b, we're going to put in a negative 1 and a positive 24x. I'm going to put the 24 with the 3 because I know that 24 and 3 are factors, or 3 is a factor of 24. And then we've got negative 1x, or you can just say negative x. And then you've got your original c, negative 8. And we put the negatives together. That's nice. All right, now factoring by grouping. So we have 3x squared plus 24x. What can I factor out? I can factor out a 3x. So I get 3x divided by 3x squared divided by 3x gives me x, and a positive 24x divided by 3 is a positive 8x. And you can tell I was secretly doing it over here on my calculator just to make sure. And then over here, we have, make sure you note that the negative sign goes with it. We have a negative x minus 8. That shouldn't be an x. I never notice until I have to match them. All right, what can I divide them both by? Nothing really, so we'll just say 1. But it has to be a negative 1, sorry. If that's negative, if that middle term is negative, your divisor has to be a negative, or else you won't get that positive binomial factored out. So negative x divided by negative 1 is a positive x. Negative 8 divided by negative 1 is a positive 8. And then that all becomes, we take out the x plus 8, and then we have 3x minus 1 as our other binomial. Good? All right, there is a formula for the difference of two squares. It would still work to do this method, but there is a formula. So the formula for the difference of two squares is anytime you have a squared minus, because it's difference, right? Difference means minus. A squared minus b squared equals a plus b times a minus b. Good. So you just have to take the perfect square of your first term and your second term and write them as those two, right? So in this case, a squared is 9x squared. If we took the square root, remember the opposite? So the opposite of the square is the square root, and it's this button right here. So the square root of 9. You can't put a variable under there because it won't really work. Square square root of 9 is 3, and the square root of, we could say like, instead of a variable, we can just put a number instead of that variable. Anything squared is itself. The square root of anything squared is itself. So the square root of 9 is 3, and the square root of x squared is just going to be x. So if a squared is 9x squared, then a is just going to be 3x, right? And for b, right, we've got b squared is just b squared. So b is going to be the square root of b squared, which is just b. So what you need to do now is fill those in. 9x squared minus b squared is, a squared is 9x squared, so a is just 3x, and b is just b, so 3x plus b, and 3x minus b. Good? Oh, sorry, it wasn't b squared, it was 4. Ignore all that. That was correct. But our b is actually 4. So b is 4. Again, if you want to use the square root button, you just say, what is the square root of 4? It is 2. So if b squared is 4, b is 2, and then we're going to put those back in there, right? So we've got 9x squared minus 4, because it has to be a minus for it to be a difference of two squares, is 9x squared. The square root of 9x squared is 3x plus the square root of 4, not negative 4, the square root of 4 is 2, and then just do it again with a minus sign between them, times 3x minus 2. Done. If you were to multiply all of that out, you would get 9x squared minus 4 as your answer. Here, number 13, it says factor the polynomial completely, but we can see we just did a difference of two squares. We see that there are some similarities, right? There's a minus sign. There's only two terms, a and the c, and that these are both perfect squares. So the square root of 4x squared, if a squared is equal to 4x squared, and we take the square root of both of those, we get that a is equal to 2x. Let's see if I get this, do this one a little bit more straightforward. And then we have minus 25, but remember the minus is part of the difference. So we don't say negative 25, we just say that b squared is the positive 25. We take the square root of both of those. The square root of b squared is b, and then the square root of 25 is 5. Good. So we'll use that same formula. A squared minus b squared equals the quantity a plus b times the quantity a minus b, and we get that 4x squared minus 25 is equal to 2x plus 5 times 2x minus 5. Good. All right. Number 14. We have y to the fourth plus 8, sorry. We have y to the fourth plus 8y to the third plus 12y squared. And we want to factor it completely. Now, the first thing I see, there are no numbers that have a common factor, but there are a lot of y's. That means that we can divide each of them by the smallest y. So we can factor out or divide them all by y squared. So that now becomes y squared times y to the fourth divided by y squared is just y squared. Positive 8y to the third divided by y squared is a positive 8y. And then we have positive 12y squared divided by y squared, so that's going to be positive 12. Good? All right, that's not factored completely because we still need to check that y squared plus 8y plus 12 can't be further factored. We saw another one of these where we just factored out the greatest common term, but that one had an x here and a y here. Now that we have all the same term, the same variable, we can continue factoring. And now we're just going to do it the same way that we did those other ones where a is 1. So it needs to multiply to equal a positive, sorry, it needs to add to equal a positive 8, multiply to equal a positive 12. Those are all positive, so our terms are going to be positive. 12 would be 1 and 12. That does not add to 8. What about 2 and 6? That does add to 8. So y squared plus 8y plus 12 is going to become x plus 2 times the quantity x plus 6. However, don't forget that we factored this out, so that also needs to be included. So we have y squared times x plus 2 times x plus 6. Good. So that is the factored form. That was the standard form. This is the factored form. Good. All right, here we're going to reduce the rational expression to lowest terms. Now, what you want to do is you want to factor these two binomials as much as you can before you do anything else. Good. How can we factor x squared plus 2x? What can I factor out of both of those? I can factor out an x, right? So that becomes x times x squared divided by x is just x, and then positive 2x divided by x is just 2. And then we'll do the same to the bottom, all right? So that becomes x times the quantity x plus 2, and then on the bottom we've got 4x plus 8. What can I factor out of both of those? I can factor out a 4, and that becomes 4. 4x divided by 4 is x, and then 8 divided by 4 is 2. So now I'm going to rewrite it. Okay, I'm going to rewrite my fraction. X squared plus 2x becomes x times the quantity x plus 2. And then on the bottom, 4x plus 8 becomes 4 times the quantity x plus 2. And those are just equal to each other. Right? Now we're reducing it, so we want to take any factor that is common to both the top and the bottom and get rid of it. What is common to both the top and the bottom? It is the x plus 2. So we are left with x divided by 4 as that rational expression in its lowest terms. Okay, number 16 asks us to subtract the fractions. So here we were reducing, simplifying, kind of dividing. Here we're going to subtract. Now remember, to add or subtract fractions, you need the same, this is the numerator, the denominator. You need the same denominator on both fractions to be able to subtract between them, and you don't subtract the denominator, okay? So it's not 2x minus the quantity x minus 3 divided by 5x minus 9 minus the quantity 5x minus 9. You just keep those the same. So whatever happens to the top, the bottom is still that same binomial that both of them shared, 5x minus 9. And then here you have 2x minus x minus 3. Be careful with subtraction. Minus, you're going to need to distribute that minus sign to both the x and the negative 3. Okay? So here we have 5x minus 9 is going to stay the same. And then 2x minus the quantity x minus 3. I'm going to put the 2x, and then we're going to distribute that minus. So that's a negative 1 times x becomes a negative x. And then the negative 1 times the negative 3. Negative times the negative becomes a positive, so it's plus 3. Good. So now you have 2x minus x plus 3, which I know I'm just rewriting for no reason, over 5x minus 9. 2x minus x gives us 1x, or just the letter x, because there's just one of them, x plus 3 over 5x minus 9. And you are done. Good. All right, we're going to move on to simplifying an expression, assuming that the variables are positive. So you don't need to do anything with the variables. So we're taking the third root of negative 216. I would just put that into my calculator, right? We've done a little bit of this. Remember that to add we only need to look at the degree here. You could also call it the index. So you're looking at the degree here, it's not a 2, so you can't just use that button. That won't work. If we use that and we did 216, it wouldn't be the same as if we did 216. Also remember that it's a negative. So you want to do negative, that's a period, not the subtract sign, negative 216. Now, if this is an odd number, that will still work. So don't worry, it won't do an error. So the third root of negative 216 is just negative 6. And then put x to the fourth. Let's look at x to the fourth because we don't know what that number is. So that becomes negative 6, and you still have the third root of x to the fourth. And I'm just going to write that all out, write out all those x's, and then you put things into groups of 3, right? So negative 216 was just like negative 6 times negative 6 times negative 6. We found 3 of them and we took them out. Good? So the third root of x to the fourth becomes the third root of x times x times x times x, right? Because that's x to the fourth. It's just x times itself 4 times. We take out the group of 3, just like the 3 negative 6's became negative 6 on the outside. 3 of these x's will become an x on the outside. So we still have that negative 6. Those 3 become an x. Don't forget, though, that we still have 1x under here, and that this index needs to be a 3. Okay, so the final answer is negative 6x times the third root of x. Good. All right, now we've got a fourth root. If you have this calculator, go down to here where it will let you put in your own number for that, 4. And then the number is 1024. Darn it. Okay, so that was not a whole number. So now we have to split 1024 into factors. And then if any of those factors can be removed because it's to the power of 4, right? So what I would do is I would say, what is 2 to the power of 4? It's 16. What is 3 to the power of 4? 81. 256. So I would take 1024 and divide it by each of those numbers. Oh, perfect. All right. So instead of 1024, we're going to change it to the fourth root of 256 times 4. And 256 we see is just 4 times 4 times 4 times 4, right? So if we did 4 times 4 5 times, we would get that number. So another way to write it would be the fourth root of 4 to the 5th power. All right, so there's 5 fours. Now we can take out 4 of them, put them on the outside. So now we have 4 on the outside and 1 4 remaining on the inside because it was 4 to the power of 5. Now for the x's, we do the same thing. We have 9 x's, so that is 8 minus 1, right? And we want groups of 4. That's 1 x out, and that's another x out. So that becomes x times x times the 4th root of x. X times x we can change to x squared. Good. So now we've got the 1024 becomes 4 on the outside, 4th root of 4 on the inside. X to the 9th becomes x squared on the outside, x under the radical, and then y to the 12th. 12 divided by 4 is just 3. So our final answer is 4x squared y to the 3rd times the 4th root of 4x. Good. Y to the 3rd, because you can just take that y to the 12th and divide it by 4, and you get y to the 3rd. Or you can do 12 y's. Right? And then just dividing. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. You have 3 groups. So 3 come out. Good? Okay. Here we're simplifying the expression 2 squared root of 35 times 5 squared root of 7. All we're going to do is we're going to multiply the 2 times the 5 and then the 35 times the 7 and see if we can simplify it. We can actually try to simplify and make sure we can't simplify 35 before that. So you want to make a list maybe of perfect squares. Like we've got 2 times 2 is 4, 3 times 3 is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, but now we've gone past 35. So can you divide out any of these numbers from 35? I do not think you can, so we'll just go ahead and multiply. 2 times 5 becomes 10, and under the square root we have 35 times 7, which is 245. Just go ahead and make sure it's not a perfect square, because that's always nice. Did I write it down right? Yeah. Okay, so it's not. And now you want to take it and maybe divide it by these numbers. 245 divided by, what would it be? 49 would be 7 times 7. 81 would be 8 times, no, that's 9 times 9. 8 times 8 is 64. And then 81. So we're just making a list. And then you have 100. I don't think there would be anything above that. 11 times 11 is 121. So you can now take 245 and divide it by those numbers. 245 divided by 121. 245 divided by 100, no, divided by 81. 64. 49. 49 and 5. Perfect. So that means keep the 10 on the outside. 245 becomes 49 times 5, or we can also write it as 49 is 7 times 7, right? So we have 7 times 7 times 5, and we're going to take those two sevens out, put them in front. So now that's 10 times, because this is a multiplication, because there's nothing between them, 10 times 7 square root of 5. So that's 70 square root of 5. You can also check that in your calculator by just saying, so here's a trick, right? If you have a multiple choice question, square root 35 times 5 square root 7 is that number. And then if you do 70 square root 5, do you get that same number? So that's how you know you have a good answer. All right, for number 20, we're just solving the equation 2 minus x equals 4x plus 22. What you want to do is you want to isolate all of the variables on one side. So right now we have a negative x on this side and a 4x on this side, a constant 2 here and a constant 22 here. So we want to get them all on the same side. I'm going to write over here 2 minus x equals 4x plus 22 just to have a little bit more space. Now, because this is a negative x, it doesn't really matter which side you move them to, and I usually move them to the left just because that's how you see variables. But because this is a negative and that's a positive, I want to add this x to both sides. That makes the x's positive. It ensures that the variable remains positive, which is easier to divide by, right? 4x plus x becomes 5x plus 22. Now you need to subtract that 22 so that everything that is not the variable is not on the same side as the variable. The equal sign is just a big wall. 2 minus 22 gives you a negative 20 because it's just like subtracting. 22 minus 2 is 20, but the negative sign is with the bigger number, so it's going to be a negative answer. 5x because that just goes away. Good. And then we're going to divide both sides by 5 to get the x alone, and we get negative 4 equals x. And you can kind of see there we had to divide a negative by a positive. So even if we had moved that negative 4x over and it had been negative 5x, it would have been negative 5x on this side and positive 20 on this side. And it still would have ended up as x equals negative 4. Good. So the solution set is x equals negative 4. Here we have 1 plus 9n equals 5n plus 9. Again, I'm going to take the bigger variable and move everything up that way. So negative 5n, negative 5n. So we've got 1 plus 4n equals 9. Subtract 1. And we get 4n equals 8. Divide both sides by 4. And we get n equals 2. Good. All right, here we have 5 times the quantity 4x minus 4 minus 6 times the quantity x plus 4 equals negative 2. What we want to do first to solve the equation or solve for x is to so this is the factored form. We're going to distribute the 5 to the 4x and the negative 4, and we're going to distribute the negative 6. Make sure you see that that's a negative 6. The negative 6 to the x and to the 4. Good? All right, so 5 times 4x becomes 20x. 5 times negative 4 is negative 20. Now we have a negative 6. Negative 6 times x just means minus 6x or negative 6x. And then the negative 6 times a positive 4 becomes a negative 24 equals negative 2. Now we're just going to combine like terms. Negative 20 and negative 24 become negative 44. You could hear my hesitation, couldn't you? And then 20x minus 16x, so 20 minus 16 is 14x equals negative 2. Now we're just doing the same thing we did in number 20 and 21, which is get the variable to one side. Good? So we're going to, since the variable's over here and it's positive, we're going to add 44. We're going to move that negative 44 by doing the opposite. 44 minus 2 is 42. Those cancel, and we have 14x equals 42. We're going to divide both sides by 14. And you get 3. So x equals 3. Good? Okay. Number 23, same thing. So we're just going to take that -2 and distribute it here, and that -2 distribute it here. So we have -2 times 5 minus 6x minus 2 times x minus 1 equals 6x. -2 times 5 is a -10. -2 times -6 is a positive 12x. -2 times x is a -2x. -2 times -1 is a positive 2 equals 6x. Now we have -10 and 2 becomes -8, right? And then here we've got positive 12 minus 2x is 10x equals 6x. Now I want to move the variable to one side, right? The variable's on both sides right now. You could move the 6x over here so that it stays positive and then move the 8 over here, or not, right? It's one less step to not do that, so we'll try that this time. So we'll subtract 10x from both sides. Now I've got nothing. I've got -8 equals 6 minus 10 is -4x. So we have negative on both sides. We're going to divide by -4. Divide by -4. And negative divided by negative makes it positive, so it's x equals 2. Good? All right. Now we need to solve an equation with fractions. All right, so to work with the fractions, we just want to take a look at what we have. We have 1/4 of x, or 1/4 times x, minus 9 equals 3/8 x, or 3/8 times x. So we see that the two fractions are um, parts of the variable. So we can put those, we want to group those together and combine those fractions, right? The constant, there is no constant that is a fraction. So that the -9 will just stay there. So we can start by moving, just like we do any other time that we need to solve for x. So we have 1/4 x minus 9 equals 3/8 x, right? Now, which one of those is bigger? I think 3/8 is a little bit bigger than 1/4. So I'm going to move the 1/4 x. Are they both positive? Yeah. I'm going to subtract 1/4 x from both sides. Now, though they're both x's, they're not, the fractions aren't common, so we're not going to, we can't directly subtract them. So now we have -9 equals 3/8 x minus 1/4 x. Good? All right, and we need to combine the 3/8 x and the 1/4 x. The way that we're going to do it is we need the denominators to be the same. So right now we have an 8 and a 4. How can we make those the same? Well, we can multiply 4 by 2, or we can divide 8 by 2. It's much easier to multiply, so we're just going to take this whole fraction, multiply the top and the bottom by 2. And what we'll have is -9 equals 3/8 x minus 2/8 x. And now we can just subtract 3 minus 2 equals 1/8. So now we have -9 equals 1/8 x, right? And now 1/8 x is the same as saying that it is x divided by 8, or 1x divided by 8. The x is next to it is also in the top of the fraction. Okay, so we see that x is being divided by 8. That's supposed to be a 1 to clarify. X is being divided by 8, so what we're going to do to both sides is multiply by 8. Eight times -9 is a -72 equals x. Good, and so our answer is -72. You can put that in and make sure. 1/4 times 72 gives us 18. Oh, sorry, -9. And then 3/8 times 72. Make sure you use the fraction, or use the parentheses. It's in the middle. Oh, because it's a -9. Negative 72. Well, thank goodness I only did it wrong when I was checking my answer. That's nice. That's unusual. All right. I'm going to insert a negative. 72 minus 9 is negative 27. And now we have 3/8 times negative 72, and it'll give us negative 27. And to show you what I mean by the x, if it's next to them, is always in the top, you can also say 3 times negative 72 divided by 8, and it'll give you the same answer. All right, one more fraction. We have 4/3 p equals 3/2 p plus 4/3 again. Now, since those are together, you'd think, oh, I'll just subtract 4/3 from that and it'll go away. But remember, the 4/3 and the 3/2 are with the p, so those need to be on the same side. 4/3 p equals 3/2 p plus 4/3. Which one of those is bigger? 3/2 is 1.5. 4/3 is 1 1/3. So I'm going to subtract. So I'm going to subtract 4/3 because it's smaller. 4/3 p from both sides. So I just have nothing on this side, right? There's nothing. And then I have 3/2 p minus 4/3 p plus 4/3. So I guess I shouldn't have done it like that. I should have moved it back. I'll move this one over. Minus 4/3 minus 4/3. And what we've got is negative 4/3 equals 3/2 p minus 4/3 p. Good. Now, we need to find a common denominator. So we're going to multiply this one, the top and the bottom, by 3. Here we're going to multiply the top and the bottom by 2. This side stays the same. 3 times 3 is 9. 3 times 2 is 6. 9 6p minus 4 times 2 is 8. 3 times 2 is 6p. Now we have 9 6p minus 8 6p, and we have negative 4/3 equals 1/6p. And remember, that's the same as saying that the p is up here. So we have negative 4/3 equals p divided by 6. So we just need to multiply both sides by 6. I would just put it into your calculator. Negative 4 divided by 3 times positive 6 is negative 8. So negative 8 equals p. Here it's negative 8. What did we say it was over here? Negative 72. Good. All right, for 26, we need to solve the equation 7 divided by 4x minus 3 equals 2 divided by x plus 2. When you have fractions that are set equal to each other that you want to solve, what you want to do is you want to multiply this numerator by this denominator, put that on one side, is equal to, and then multiply this numerator by this denominator. 2 times 4x minus 3. Good? Because what you're doing is you're taking that and you're multiplying both this side and that side by it, and what you're left with is 2 and that because it cancels out on this side. Then you're taking everything on this side and multiplying it by both sides, and you're left with 7 times x plus 2. So 7x plus 2 becomes 7x plus 14 equals 2 times 4x becomes 8x minus 6 because 2 times negative 3 is a negative 6. Now you're just going to solve the way we usually solve. So I'll subtract 7x from this side, and I get x. And I still have a 14 over here and a negative 6 over here. So I will add 6, and I get 20 equals x. So the solution set is 20. Good? Nope. That's down here. 20. All right. 27 is solve for G. Q equals 3G plus 3V. So basically you just want to get G alone, right? Pretend like the rest of them are numbers. Q equals 3G plus 3V. G alone means we're going to, right now it's being multiplied by 3 and 3V is being added to it. So the first thing we're going to do is subtract the 3V from both sides. Now I have Q minus 3V equals 3G. Now G still needs to be isolated, so I'm going to divide it by 3 because it's being multiplied by 3. Divided by 3, divided by 3, and we get G equals Q minus 3V all divided by 3. Good. Here we're going to solve for T. We've got U equals capital F plus capital F times R times T. What is happening to T? It's being multiplied by R, it's being multiplied by a capital F, and F is being added to it. So first we're going to subtract the F, not 7. And we get U minus F equals F R T. Now T is being multiplied by F and R. Don't worry about moving them one by one, move them all together. They're being multiplied, so we want to divide them. It's very confusing if you just start, you only do one and then you have a fraction over here and you don't know what to do with the rest of it. Good, and then that will cancel those and you'll just have T equals U minus F times capital F over R. So it's U minus F divided by F R. Good. All right, number 29. Write this expression as a pure imaginary number, negative square root of negative 9. So an imaginary number, remember, is I is equal to the square root of negative 1. I squared equals negative 1. Those are the rules about imaginary numbers. Good. So negative 1 is I. Because if we try to take the square root of 9, sorry, the square root of 9 would work. Let's do the square root of 9. The square root of 9 is just 3. But the square root of negative 9, they will say it's not a real number. So we have to use imaginary numbers. How are you going to get 9 to become negative 9 to become negative 1? You just say the square root of negative 9 is also the square root of negative 1 times 9, right? Because a negative 1 times a positive 9 gives you negative 9. And now we're going to change that to, I'm going to move it down here. So equals negative square root negative 1 times 9. We understand that, right? Because negative 1 times positive 9 is a negative 9. And then that square root of negative 1 becomes an I, but it is, right? It's outside, right? So now we have negative I, because we took that negative 1 outside the radical, and now it's just negative I because of that negative sign. Square root 9. And what's the square root of 9? The square root of 9 is 3, so now it's negative 3I. Good. And I want to highlight where that negative sign came from. So that was just, has been in front the whole time. That's that. Okay. And then the negative 1 under the radical became the I. And the square root of 9 became the 3. Good. Okay. Number 30 asks us to write the expression in the standard form a plus bi, which is just a complex number because it includes imaginary numbers and real numbers. So all you're going to do, that is subtraction sign. Okay. All you're going to do is take the quantity negative 4 plus 6i and subtract the quantity 2 minus 4i from it. The hardest part is going to be remembering to distribute that minus sign. So we have negative 4 plus 6i. I'm going to distribute it now. Negative 1 times 2 is a negative 2. Negative 1 times a negative 4i is a positive 4i. Good. I didn't even need these parentheses because we're not multiplying because there's a sign between them, but I wrote it because it was there. So now we have negative 4 plus 6i minus 2 plus 4i. And all we're going to do now is combine like terms as though that I were a variable. So we have plus 4i plus 4i. That becomes 8i. And then we have sorry, obviously not. Ignore that. 4i and 6i. 4 and 6 become 10i. I don't know why I did the i's first because you're always supposed to put them in the back, but maybe to just remind you. And then we've got a negative 4 and a negative 2. So that becomes a negative 6 as your whole number. So I'm going to switch them places. Negative 6 plus 10i is in standard form. A plus bi. The I should always be at the end. Good? Okay. Negative 6 plus 10i. 31, we're doing the same thing. We're subtracting. So I'm not going to put a parentheses this time. So we have 6 minus 6i. I'm going to start distributing that minus. Negative and a positive become a negative 9. And then a negative and a positive become a negative 8i. Now we're just combining like terms again. Let's start with the right ones this time. 6 minus 9. Make sure you include that negative sign. 6 minus 9 is a negative 3, right? Because the difference, 9 minus 6 is 3, but the bigger number is negative, so we're going to make it a negative 3. And then we've got negative 6i minus 8i. When they're both negative, it's like you're adding. So 6 and 8 together are, sorry, 14, right? Minus 14i. Because 6 plus 6 is 12, and 8 plus 8 is 16, and halfway between 12 and 16 is 14, but I should have just not done it like that. So there's your answer. Negative 3 minus 14i. Here, though, for 32, we are multiplying them. All right, so it's just like FOIL. So we're going to do first 3 times 5. Outside, 3 times positive I. Inside, negative 9i times 5. And then last, we've got negative 9i times I. And what does that give us? 3 times 5 is 15. 3 times I is 3i. Negative 9i times 5 is a negative 45i. And negative 9i times I is a negative 9i squared. Good? All right. We have a 15, a 3i, a negative 45i, and a negative 9i squared. Right now, you can either take that I squared and change it to a negative 1, or you can do it at the end. I want to do it right now so I don't, just because. So we have negative 9, and remember, if I is equal to the square root of negative 1, then I squared is equal to negative 1. So I squared is just negative 1. And then negative 9 times negative 1 just becomes a positive 9. So we've got 15 is that first term, plus 3i because it was a positive, minus 45i plus 9, because it was a negative 9i squared. The I squared became a negative 1, and those became multiplied together became a positive 9. Good. Now we just combine those two middle terms. 15 minus 42i plus 9. Okay, let's continue combining like terms. 15 and 9 come together to give us 24. That always goes in front. 24 minus 42i. I feel like I was about to just leave it like that, but you have to combine these two because they are also like terms. So our answer is 24 minus 42i. Okay, we're going back to factoring. Number 33. We have 5x squared minus 34x minus 7 equals 0. Good? Okay. Can you factor anything out of there? Might be easy. No? Okay. So now we're going to make that table. We need to add to negative 34, and we need it to multiply to negative 35. Hmm. Hmm. Because 5 times negative 7 is a negative 35, and 34 was our negative 34 was our b. So you have a negative that you're multiplying to and a negative that you're adding to. That means it's going to be a negative and a positive, and that the bigger term is going to be the negative term. The first term I'm going to use is a positive 1 and a negative 35, which does add to negative 34. So I'm going to, that's the next step. We found it. We found it so fast. 5x squared, I'm going to say minus 35x, right? Because I take that b and I replace it with this and this, plus 1x minus 7 equals 0. Good. Now we're going to do factoring by grouping. Our first group is this one. 5x squared minus 35x. I can divide them both by 5x. 5x squared divided by 5x gives us x. Negative 35 divided by 5 is negative 7. X divided by x gets rid of the x's. Good. Here we have a positive. So x minus 7, nothing in common, so I'm just going to do 1 plus 1 x minus 7 equals 0. Good? Okay. Group the common x minus 7. 5x plus 1 equals 0. Now you've got two groups, okay? It's saying solve the following equation, so we're not just factoring it, we have to solve it all the way. So what you want to do is you use this rule that says if this is being multiplied by this and they equal 0, then one of those two has to be 0. So what you want to do is just take that first binomial, set it equal to 0, and solve for x. You want x alone on that side, so we're going to add 7, x equals 7. Okay, we're going to do that with the other one. 5x plus 1 equals 0. You want the x alone, so we're going to subtract 1, x equals negative 1, except it's not x, it's 5x equals negative 1. X is still not alone, it's being multiplied by 5, so we're going to divide it by 5. X equals negative 1/5. And so our two answers for number 33 are negative 1/5 and 7. Good? All right, for 34, solve the following equation by factoring. Remember, you can use the rule of uh, the difference of two squares, right? Because that's a perfect square and that's a perfect square. A squared minus b squared equals a plus b times quantity a minus b, right? So if my a squared is x squared, that means a is equal to x. And if b squared is 64, the square root of 64 is 8, right? So that means that x squared minus 64 is equal to x plus 8 times x minus 8. Good? Okay. And that was all set equal to 0. So now we take x plus 8 equals 0. We subtract 8 from both sides. X is negative 8. And then we have x minus 8 equals 0. Add 8 to both sides. And we get x equals 8. So the solution set is negative 8 and 8. 35 asks us to solve it using the square root method. The square root method is simply to take the square root of both sides. Currently you have x squared on this side, and you have 169 on that side. So the square root of x squared is just x, and then the square root of 169 is 13. X equals 13. However, always remember that there is a positive and a negative that it could be, because what we're saying is this number squared is 169, so we know that 13 squared is 169, but negative 13 squared is also 169. So anytime you're taking a perfect square to find the value of x, you need to say plus or minus. So it's 13 or negative 13. Good? All right, for number 36, they're asking us to use the quadratic formula to find solutions. We generally use the quadratic formula when there is nothing we can find with that A-B method, where you need to find two terms that add to equal negative 4 and that multiply to equal negative 4, right? So there's not two numbers, a positive and a negative, that would multiply to equal negative 4 and that would add to equal negative 4. What you need to do is use the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4, sorry, ac all over 2a. Good. And then you've got your a, b, and c here. So a is 1, b is negative 4, and c is also negative 4. And we're just going to plug those in. Okay. So we have x equals negative 4. Don't forget that b is a negative 4, plus or minus the square root of negative 4 squared minus 4 times a, which is just 1, times c, which is also negative 4, all over 2 times a, which is just 1. Good. But now we're going to simplify this. Negative 4 becomes positive 4, because a negative times a negative is a positive, plus or minus the square root of 4 squared is 16. So okay, that's negative. Negative times a negative makes a positive. So negative 4 times negative 4 is 16. Negative 4 times negative 4 is also 16. So 16, negative times a negative becomes a positive. 16 divided by 2. Good. 16 plus 16 is 32. So we have 4 plus or minus the square root of 32 divided by 2. Now we want to think about, can we take the square root of 32 and simplify it at all? It's not a perfect square, right? The square root of 32 is not perfect. So you can say, well, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Do any of those, can you divide 32 by any of those? 32 divided by 16 is 2. Perfect. So this becomes, I'm going to go sideways now, 4 plus or minus the square root of, what would we say, 16 times 2? And 16 is 4 times 4. 4 times 4 times 2 over 2. These come out. And now we have, it doesn't go with the 4 because we have the signs right here. 4 plus or minus 4 square root 2 divided by 2. Good? So now we've simplified under the radical. Now we just need to simplify the fraction. And that's just, remember, a fraction is just a division sign. So 4 divided by 2 is 2. 4 divided by 2 is 2. Square root 2. Good. So our answer for 36 is 2 plus 2 square root 2 and 2 minus 2 square root 2. I guess that one should go in front because it's smaller. But those are the two answers for 36. So this just means we're going to use the quadratic formula, but we can use imaginary numbers or complex numbers if you want. Okay. If it's a question like this, it's probably not going to be factorable, so you don't really need to check whether it's factorable. I mean, you can. But you can kind of just go straight to the quadratic formula. So we have x squared minus 6x plus 10. That means a is 1, b is negative 6, and c is positive 10. Good? All right, so we have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a becomes x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 10, all divided by 2 times 1. Good? Okay. So we're just going to simplify that. X equals positive 6 plus or minus square root of 36 minus 40 all over 2. I always make these so awkward looking. It seems like such a big equation, and so I just have too much. 6 plus or minus the square root of 36 minus 40. So instead of just taking the square root of 36, the square root of minus 40, you have to combine them. 36 minus 40 is negative 4 divided by 2. Usually you would stop here because that's an imaginary number, but because it's an imaginary number, we're going to take, and it said in the complex number system, we're going to take that, turn it into an imaginary number, and continue solving it. X equals 6 plus or minus the square root of negative 1 times positive 4 over 2. X equals 6 plus or minus, and then that becomes I, and the square root of 4 is just 2 over 2. So I need to switch the order. X equals 6 plus or minus 2i divided by 2. And then we're just going to divide everything by 2. X equals 6 divided by 2 is 3. And then 2 divided by 2 is 1. So x equals 3 plus I, 3 minus I. Good? Okay. I'm going to skip number 38. It's the same idea. 39, find the real solutions of this equation. They're asking us to we have the square root of 5x minus 4 is equal to 4, so we just need to get the 5x alone, or so we need to get the x alone. It's being multiplied by 5, and then 4 is being subtracted from it. So what you want to do is get rid of that square root. What's the opposite of a square root? We square it, right? And so now that cancels that, and we just have 5x minus 4 equals 4 squared. Good. 4 squared is 16, so it's 5x minus 4 equals 16. We still want the x alone, so we need to subtract that 4, and we'll just have 5x on this side equals 16 minus 4, right? Ooh, good thing I finally wrote it down because it's plus 4. 16 plus 4 is 20. Now we're going to divide both sides by 5. X equals 4. Good? All right, same thing here. If you have the square root, you just want to square both sides to get rid of that square root. So now I have 4t plus 9 equals negative 5 times negative 5 is 25. I wanted to say 10, but that's just adding. All right, let's subtract 9. And you have 4t equals 25 minus 9 is 16. Divide by 4. T equals 4. Now, when you're doing solutions like this, you always want to check your answer, make sure it's true. All right, so here we have x equals 4, so we're going to put it in. The square root of 5, I'm going to put in a 4 for the x because we said it's 4, minus 4 equals 4, so that's true. Down here, we also found the number 4, so we're going to say this the square root of 4 times 4 plus 9, is that going to equal negative 5? It equals positive 5. So what you want to remember about taking the square root of something is when you take the square root, it's never going to equal a negative number. So as soon as you see a problem like this, where you have a square root on this side with a variable under there, and it equals a negative number with no variable over here, that's always an empty set because there's no way that you can take the square root of something and get the answer as a negative. Okay? All right, here we've got the square root of x squared minus x minus 4 equals x plus 4. Again, we're just going to square both sides. It's just a little harder because this is a binomial that we're squaring. Need a new color because that will confuse with that. I'm going to put it up here. So we have x squared minus x minus 4 equals x plus 4 squared, which is just x plus 4 times itself. So we're going to write it like this. Good. That side stays the same. Let's FOIL this side. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And then 4 times 4 is 16. And over here we still have x squared minus x minus 4. Let's combine like terms over here. So that becomes x squared plus 4 is 8x plus 16. Now, what you want to do if we are finding real solutions of the equation and you have an x squared and an x is you want to see if you can put them all to one side, set them all equal to 0, and then factor them. Okay, so we're going to set it equal to 0 if we can. I have an x squared on this side and an x squared on this side. I will subtract x squared from both sides. But if I do that, it drops out of both sides, right? So that's gone, and we have negative x minus 4 equals 8x plus 16. So now we lost that x squared, and now we're just solving for x again. So we have a negative x and a positive 8x. I'll x, add x, negative 4 equals 9x plus 16. Good. Again, we just have one variable now and two constants. We're just going to move that over here. So we have negative 20 equals 9x. X is being multiplied by 9, so we need to divide it by 9. And we get x equals negative 20 over 9. And again, just throw that. If you ever get a fraction as your answer, just throw it into your calculator to make sure you can't simplify it, just so that you have it in simplest form at the end. Our answer is negative 20 over 9. Good? Okay. Here we have 2x minus 5 is greater than 9. And we need to solve the inequality and graph the solution. Remember that these mean includes, and these means starts at but does not include, okay? So it looks like our answer is probably going to be A7, almost said 8, 7, but is it greater than or equal to, less than or equal to 7, okay? One more piece of paper. We have 2x minus 5 is greater than 9. We just want that x alone, preferably on that side, just because it make it less confusing. So I'm going to add 5 to both sides. And what I get is 2x is greater than 9 and 5 is 14. X is being multiplied by 2, so I'm going to divide it by 2. And I get x is greater than 7. Not greater than or equal to, just greater than. Greater than 7. Greater than means it's going this way, right? Bigger. And it does not equal 7. So I'm going to pick D. X is greater than 7. Here we have 4x minus 3 is greater than or equal to 3x, 3 plus x, sorry. 4x minus 3 greater than or equal to 3 plus x. All right, we want all of our x's on one side, so I'm going to subtract x, subtract x. I get 3x minus 3 greater than or equal to 3. Move that over there so that all our constants are on the other side. 3x greater than or equal to 6. Does that feel right? Well, let's see if we have a graph that matches that, right? Divide both sides by 3. X is greater than or equal to 2. 2, 4, 2. And we said greater than, which means it goes that way, or equal to, which means it needs that, right? If it equal to means it includes. It includes the 2. This does not include the 2. It starts at the 2 but doesn't include it. Good? So the solution is expressed in set notation as x is greater than or equal to 2. It is expressed in interval notation as beginning at, so for interval notation, after you pick the graph, you oh, sorry, could you see that? So set notation is just what we have. X is greater than or equal to 2. We put it right up there, but they already have the x. So you just put the greater than or equal to 2 part. Interval notation, once you've picked your graph, you just describe your graph. So my graph starts with a bracket at 2, and then it goes, where does it go? It goes forever Forever always gets a parentheses, never a bracket. Okay. I think for 42, I was supposed to put it in interval notation. So in interval notation, it's confusing for me too. So I just look at my graph that I already chose. I started with a parentheses. I started at 7 and it goes forever. Forever always gets parentheses. Good. Okay. Here we've got 0 is less than or equal to 3x minus 15, which is less than or equal to 6. Good. I'm going to add 15 to all the sides because these are just like an equal sign. Anything you do to this part, you have to do to the other two parts. So now I've got 15 less than or equal to 3x, which is less than or equal to 15 plus 6, which is 21, I think. So I took that negative 15, and it means I added 15 here, added 15 here, added 15 here, which gave me 15 less than or equal to 3x less than or equal to 21. Good. Now I just need to get rid of the 3 that is being multiplied by dividing it. 15 divided by 3 is 5. That just becomes x. And then 21 divided by 3 is 7. So we're saying x is greater than or equal to 5, but less than or equal to 7. X. So set notation is 5. It's greater than or equal to x. Less than or equal to x, which is less than or equal to 7. And because they didn't have an x here, I feel like I did these wrong now. So I'm going to say x. Make sure you include an x for that one. So do it like that. Don't do it like that where I left out the x. And interval notation, so let's pick a graph. X is greater than or equal to 5. So where is 5? Here, and it's greater than or equal to, it includes the 5. And then it stops at 7 and includes 7. I'm going to pick D, and then I'm just going to write that graph as interval notation. So it starts like this. It starts at 5 and it ends at 7. And how does it end? It also ends like this. That's how I do it. Good. Okay. Here it says find the real solutions if any of the equation. When you have absolute value, you're just going to take, once you've got your variable, once you've got your absolute value bars alone on this side, you want to then take this and split it into 2. All right, so we have 2x, the absolute value of 2x is equal to 8. What you want to do now is you want to do two different equations. So you're going to have two different answers most likely. So now we're going to lose the bars. 2x equals negative 8. 2x equals the original equation. So I made everything on this side negative, and I kept everything the same. 2x equals negative 8, divide by 2, divide by 2, and I get x equals negative 4. Over here, divide by 2, divide by 2, and I get x equals 4. So the solution set is negative 4 and 4. Good. All real numbers is when it can be true no matter what x is. Or if x goes away and it is true, that's all real numbers. If x goes away, like cancels out, and it is not true, then that is empty. There's nothing that can make it true. Okay? So we're going to do the same thing here. We have 7x plus 3. The absolute value of 7x plus 3 is equal to 4. We're going to change it into two different equations. So here's 7x plus 3 equals negative 4. And here is 7x plus 3 equals positive 4. And now we just solve it. So we're going to subtract 3, subtract 3. 7x equals negative 7. Divide by 7, divide by 7. X equals negative 1. Good. All right, over here, 7x plus 3 equals 4. We're going to subtract 3, subtract 3. 7x equals 1. X is being multiplied by 7, so we're going to divide it by 7. X equals 1/7. So the real solution set is negative 1 and 1/7. All right, guys, last problem. Here we have 2 minus 5t plus 4 equals 21. So this is what I mean by you have to make sure that your absolute values are completely alone before you split it, okay? Because this is not alone. We have an absolute value bar, but then we have plus 4. 2 plus 5t plus 4 equals 21. Before I split it into 2, I need to get rid of that 4 on this side, so it's only the absolute value bars that are on that side. 2 plus 5t equals 21 minus 4, 17. Okay, now we can split it into 2. So now we can say 2 plus 5t equals 21, 17, right? And then 2 plus 5t equals negative 17. Good. All right. Subtract 2, and we get 5t equals 15. Divide by 5, and we get t equals 3. Over here, we're going to subtract 2, subtract 2. That's easier. Negative 19. Oh no, it's this one. Divide by 5, divide by 5, and our answer is, did I miss something? Did I write it down wrong? 17 minus 2. Oh, I wrote down it as minus 5. I wrote it down as plus 5. So that should be negative 3. Okay, so 5t divided by negative 5. Negative 5t divided by negative 5 is just t, and then negative 19 divided by negative 5 is 19/5. And that is the review for exam 1. Thanks, guys.